Hi guys, welcome back to another video. We're actually continuing right off where we started last time. I'm in fact recording this video almost straight after finishing the previous one, because I got excited about adding weapons so that we can actually deal with these enemies. So let's get right to it. The very basic weapon that I'm gonna add now is just something that will shoot like an actual projectile, which will be a separate game object, and it will fire it in a straight line, and whenever it hits an enemy, both the enemy and the projectile will be destroyed. Wow, how did that one guy get up on top of the other ones? Interesting. Yeah, the physics aspects will have to be looked into a little bit, but anyway, that should be fairly easy to do. We might not actually even have to expose anything new to Zig. I think we should have everything we need on the Zig side. We might need some new some new messages actually, but we'll see when we get that far. So how do we start doing this thing? Actually, if we start the game and just pause a little bit. So we have this aiming vector here, and this essentially tells us that which direction in the world space should the projectile travel. So it's supposed to spawn somewhere along this place and then just move in a direction like this. I think I'm not gonna do any actual physics objects for the projectiles, even though we could do that. Like maybe later on we'll have grenades or something, and they will fly in sort of an arc and like bounce off things and whatnot. And we could use the physics engine for that. But for these very simple ones, let's not do that. Let's just add an object and have all the movement and everything just in code. I think that would be the easiest thing to do. And we'll add just a very simple kind of naive even collision detection system into the game now, so that we figure out which projectiles have collided with which enemy, and then we remove both of them, and then we can later on we can think about if we want to use some kind of spatial partitioning system to speed up that check, or even use the physics engine for that check as well. But let's start very simple and just get the gameplay working. Anyway, so if we consider this case, we'll spawn the projectile just like straight inside this guy, and then we'll keep moving in this direction. So I think the easiest way to get the direction to work is to spawn the object oriented so that it's kind of sitting and pointing in this aiming direction, and if we do that, then the projectile movement code can just simply move the object forward in like along its forward vector. That should be quite easy. So let's start with that. So we'll go to our Zig code and we'll add a new file, and let's call this what do we call it? We call it like linear projectile component. And the linear comes from the fact that it just moves in a line, so it is linear. And we'll select an nice component for doing the copy-paste dance. Let's use this one. Linear projectile component, like this. And we'll probably need quite a few of these actually. So maybe we can leave most of them here just for now, and let's register it immediately. And that way we get proper error messages if we somehow miss something. So I mean that one we won't need. I'm pretty sure we won't need that one. Where was it actually used? It's used there. Let's comment out basically that part and that part, and then we'll need to do this. And this is not supposed to send enemy spawned or enemy killed messages, but it might actually want to notify the system that it has created itself. It has been created as a projectile. But I think we'll leave these out for now, which means that we'll need to do this here. All right. And now this should be. Actually, we'll probably need self there as well, won't we? This should now build. Oh. That too. And destroy. Okay. Just grabbing a bit of coffee here. Okay, so now we have a component to put our projectile logic into, and I think we'll make some simple kind of mesh for that, for the projectile, just so that we have let's see, where's our data. We should maybe just get hyper data and drag it here. What? Why does it not? Okay, needs to be there. So we have our objects here, we have characters, and our player capsule, character capsule. Let's add a projectile folder here, and like we did with the character capsule, we'll add a work folder which we can freely poke inside, and no converter is going to try to convert what we have in there. I now realize that we don't actually have Blender installed on this, so what? No, go away. Right, let's install Blender. This shouldn't take long. Yeah. And while we're waiting for that, let's just get a material here that we can then use for the, let's call it test projectile, because I'm not exactly sure what kind of projectiles we'll want in the final game, so I'm not gonna spend any time on that. Just make something very, very simple. For the time being. And we should be almost done. There we go. Okay, so Blender, s'il vous plaît. Where is it? Is it that one? I don't think it's that one. No, this is a very old version of Blender. Here we go. This is better. So spin that to the taskbar. Okay, and what I was thinking we would do is just we'll add a cylinder, and we will actually we will rotate it around the x-axis 90 degrees. We'll lower the vertex count. The radius will be much smaller. Let's make it like 0.15. And yeah, something like this, and then 1 meter should be enough. All right, so something like this. Let's try to make it into like some kind of I don't know, bullet thing. I'll need a few more of these loops here, and one loop in the front, and then we'll get this, and we'll scale it down a little bit like this, and then we'll take this and we'll scale that down. What is happening? There we go. Like I have no plan for this. I just make something. The idea here is that we'll have something where we can clearly see that, like, okay, this is the front and this is the back, and it's more about just making sure that our math is correct rather than making an actual nice looking projectile. And it will be something like that on the screen anyway, so won't see many details. Yes, and just because we can, let's actually let's like bevel this and maybe pull it up, and nope, that, and then like so, and actually we'll take just so that we have something that which has like an upper side. So now we can clearly see, like, okay, which side is up, which is down, etc. And that, I think, will be fine. This looks a little silly, I have to say. Come on, let's scale them down. Nope, not that. What? That's what I wanted. Something like that, and then, I don't know, bring that down a little bit. Just like a small detail there to which tell us, like, which side is up when we see it in the game, and that will just let us know that okay, we have the math set up correctly. We'll shade it smooth, and then we'll set some of these as sharp edges. Mark sharp. Actually, we can probably just put in an edge split modifier, and that makes it look very nice. Very nice indeed. Yeah, something like that. I don't know. It doesn't really matter. This is good enough for our use case. This face here looks a little weird, so let's do something about that. Just put it in a little bit like that. Okay, so here's our weird looking test projectile, and let's save it in the, I don't have any recents because I just installed Blender, so that would be projects, and it would be basis data and hyper data and hyper objects projectile work test projectile dot blend. Yep, save it. Come on. And we'll export that as an FBX file. Actually, let's make sure before we do that yeah, scale is correct. And this should be like, that's the front side, that's the back side, left, right. Yeah, it seems to be oriented properly. So FBX, and now we can actually just go out of there. Test projectile, we don't have the preset here currently, but the only thing we need to do is selected objects only, and C is forward in our game engine. Well, we can actually just shut Blender down. Okay, one thing I need to do here before we do anything else is add, oh, not a zip file, sorry about that. We add a text file, and we call this projectile blueprints.blueprint, and it's a JSON file, so yeah, it complains that can't convert it because it doesn't contain anything, so we just need to add like one root object to it. Like it wasn't happy about it not having anything, and now we got a new blueprint which is converted into a JSON file, and that file currently needs to be manually added here so that we load the blueprints into the game like this. Like I have a piece of code here which just figures out at runtime which ones are blueprints and loads them, but actually don't use it currently because I want to load them in a specific order so that they show up in the editor in that order. Not super important for Hyper, but for Slide it's quite nice that they are in a specific order. And now we can just refresh this blueprint, and we'll have projectile blueprints here. We don't have any objects here yet, so we can take, for example, this player character. And we'll just go here and we add a new blueprint, and we'll call this projectiles/test projectile. Yeah, we don't actually even need that. We can just go here and we can do components. We can add a mesh here, and the mesh that we created was already converted, so we can use that, and we can use the pin material which we copied earlier. So now if everything works out, we should have like a blue bullet here in the... Oh, crap. What did I do? What did I do wrong? Yeah, that's loaded and compiled. And that's still actually the wrong one, but that shouldn't cause it to crash. Like that is the one that we want actually. So projectile, test projectile, oh, test projectile character, what is that? Test projectile, that's what it's supposed to be called. So test projectile FBX and test projectile basis material, which at runtime get turned into a bin mesh and a bin material. There we go. Okay. And yeah, the blue color is perhaps not the best choice for color here, so okay, yes, thank you. Let's make it like a, I don't know, grayish something or other. Something like this, and like I typically start with the ambient, and then I raise the diffuse color a little bit, and that usually gives me something that I can live with. It's a little bright actually. It's just, oh, like this color picker in the Visual Studio Code, like it's an extension that I use. It's actually kind of flaky. Don't really like it. Okay, yeah, that gives us something that we can work with. Again, let's come up with some cooler projectiles and cooler weapons with like actual like gameplay implications later. Let's just make sure that we have something now. Okay, so it now has a transform. It's created on the client and server, in addition to the level editor and asset browser. And the mesh is created on the client, level editor, asset browser. We will want to have the new, what did we call it? Linear projectile component as well. So name is just projectile, and type is linear projectile component. Create on, I think we'll go with only server, and we'll actually need a comma there. And properties it doesn't have yet. Yeah, these things that you put in the properties, these are called blueprint properties because they're specified in the blueprint. So for example, mesh has these blueprint properties, or it actually has even more that aren't listed here. These are things that you can currently specify only for C++ components. It's something that I need to add to the Zig support at some point. They're very handy. Like this mesh component here, for example, if we go to C++ and have a look at the mesh component, it has this blueprint properties class here, which has all these members and and it gets set here, and then you can start to use those however you want. That's something that I need to add to the Zig support. That's one reason why we have all these constants with like numbers hard-coded in the Zig code currently. That those are things that would typically be put here, so that you can use the same component in multiple different game objects, and you just set different values for the properties here in the blueprint. Okay, but yes, so I think this is probably what we need for now. We can actually disconnect the game here so that it doesn't block us from recompiling it. We can always just click back like this if you want to have it later, and etc. But yeah, okay. Right. Okay, so how do we actually get one of these guys into the game now? Oh, actually, one thing that we might want to do, it's not super important either, but we have like these top level properties here. We can expose to editor. We can set this, for example, to false, so that, again, not super important for Hyper, but it might be good to set them anyway. Otherwise, the editor will show these up in the list of objects to place in the level, and we won't want that. You can also make an object editor only, or a singleton, or have some placement offset, blah blah blah, and you can disable things. But we don't want to expose these projectiles to the editor, so let's have them like that. Okay, and right, so how do we get these guys into the world? Well, the player character is supposed to shoot them using some kind of weapon, and it would make sense that every weapon has its own projectile type. Currently we have only the projectile, we don't have a weapon yet. Maybe we'll want to add that next, and then just hard code it to shoot these kinds of projectiles. So let's do that. We have a what do you call it, linear projectile component. Let's add a what do we call this? Linear projectile weapon? Maybe not. I'm not sure. Linear. I don't know. Let's just call it projectile weapon for now. .zig. We can copy that, and we'll register it as well. And I'm thinking that perhaps weapons are things that the player can collect in the level, and then use. But for now, I think we'll just add one of these weapons to the player object type. Blah. Component. What? Component, I said. Maybe I should update my Sublime text editor too. Okay, that should be fine. And now we can go here to the player blueprints, and let's add the weapon here as well. Oh, this indentation is bugging out a little bit. Name I think we'll just call this weapon for now. And type is that. And do we want to create it on the client? I think we do. Yeah, let's create another client for now. So that if we want to add like a particle effect or something to the shooting, then we can do that on the client. Yeah. Okay. And how do we then shoot things? Well, if we have the weapon component here, we can, for example, in tick, we can listen to some kind of weapon firing input action. So let's see what we had when we did the cleanup earlier. So we have an input ID fire weapon and a switch weapon, which we don't use yet. So fire weapon is a state, and a state is something that if you have like a weapon that fires like an automatic rifle, for example, when you press the fire button, that state becomes true, and when you lift it, it becomes false. And for all the frames in between, when you have it pressed, it remains true, so that you can keep firing. But that's not actually what we want here, or is it? Maybe it is actually, now that I think about it, because yeah, typically these kind of twin stick shooters actually have like weapons that fire like salvos of projectiles. Maybe we'll actually do that. That might be fun. So in that case, this state is what we want. For things that are of type action, those are things that happen only like once, and then they get reset back to false. So you need to lift the button and press it again for the action to become true again. But let's actually keep this as a state for now. That means that we can fire. We can have automatic fire for our linear projectile weapon. That sounds good. So that's the ID we wanna check. We can do it in tick. I think tick is probably the correct place to do it. And I don't think we will be receiving any messages. So let's get rid of that. That as well. Okay. What we do want though is the player aim component. And the player aim component will tell us the direction to fire in. What was it called? Like this is how you set up. We can get rid of that, and we can get rid of that, and we want to have an aim component. Actually, this is not even projectile weapon component. Sorry, now I'm doing completely wrong things. That's fine. That's projectile weapon, and that's player aim, and that's what we want. And we want the aim component here to be of that type. And what did we call it? Call it player aim. So the aim component will tell us which direction to fire those objects in. And we probably actually need to add that as like a getter here. So let's do that. Aim direction. Are these like public? Maybe they're public. Maybe in that case we don't need actually like to add a getter there. Let's have a quick look. Like, can I do this, for example? Const direction equals self dot aim component dot aim direction. Yes, but it complains about I should have done this instead. Does not support field access. Okay, right. Yeah, it's the same thing we had previously. So like, it's like if self aim component, then we need to capture it. It's like aim component, and then we can do this in effect. Yes. Okay. Okay, cool. Cool. Right, so that's what we want to do at some point, not in on parent created. This does need to be an avatar tracking component though. So let's make sure it is one. And the reason for that is, of course, that we will want to read this this input ID fire weapon if we are the avatar of someone. And like we've done previously, we want to do here if, and let's do this only on the server. Self context on server and self context get avatar host ID doesn't equal -1. Then we can do const firing, and this would be self context. What is that called, that function? So it was a state, so we want to have get input state, and then I think they're called something like input IDs. Let's have a check. Game input is what we want. Damn it, the back button on my mouse doesn't work how I expect it to in this editor. Okay, like that. And now we'll want to have a const here for the firing rate. So time between projectiles. And let's make it fire, I don't know, 2 times per second or something like that. And we'll want to have time since last projectile, and that's going to be a float 32, and we initialize it to this, what was it called, std math f32 max, was it something like that? f32 underscore max, yes. And so we can here actually do self dot time since last projectile is tick delta time, and then we can get rid of these both. We don't need that either. Yes. And if this is larger than or equal to time between projectiles, actually if firing and that, then self time since last projectile is set back to 0, and we can call self fire projectile. And let's add our private functions section here and add that function. So fire projectile void. And yes, should we check the aiming here or should we do it somewhere else? Maybe we'll actually, let's do like a direction here. Vec3, do we have Vec3 here? Yes, we do. So if self dot aim component and we can just do this and put it here and have ac dot aim direction, and that's gonna format this again. Direction like that. Does that build? Nope. Nope. Of course we want that to be an avatar tracking component. And what is that? Expected 1 argument, found 2. Oh. Come on. Yeah, okay, we have an unused blah blah blah, whatever. Let's not care about that. Okay, so now we have the direction to fire, and we don't call this more often than we're actually allowed to do. So let's do start position. That would be self context transform get position, and then we will want to create that object of that type that we already did here. So something like this, and perhaps the most interesting thing here is the orientation, which we can get rid of that and that, and let's actually add this up here. So projectile type should be this one projectile that we added here to the blueprints. It should be that. Start position and the orientation is something that we need to figure out. Yeah, and we can get rid of that too. We don't need that at all. Now we should be able to build it, I think. Right, we don't use the direction yet for anything. Okay, so to figure out the direction, the easiest way is most likely to set up this. Actually, yeah, we can create a matrix, 4x3 matrix from an orientation and a position, but now we actually want to create one from a direction, which we can definitely do, but I don't have a function for it yet. So yeah, what would be the easiest way? I think the easiest way would be to simply Oh, unless we actually have... No, we don't have any... So we actually need a... to convert to a quaternion. I don't think I have any quaternion conversion functions in Zig yet. Blah, 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 blah. From local access is actually what we want, probably. What does that look like? It goes through a matrix and then figures it out from a rotation matrix. That's annoying. That's annoying. How annoying. Okay. Yeah, I'm not terribly good with quaternions, to be honest. I get by, but I don't know any of this math by heart. But that's fine. We can live with this identity orientation for now. I will fix it later in this video, but let's make sure that we can actually just fire these guys and get them moving. And currently what we have should actually already spawn them into the world. They are not going to move anywhere, but yeah, but they are going to be placed in the world. Oh. So let's try that out. Oh, what is my firing button? Have I bound it to anything? Doesn't look like it. Let's see. Fire weapon. Okay, it's right bumper. Okay. I think I pressed that. Why didn't it work? So we have tick here. Projectile weapon component is added to the player. It's on the client and the server. If we're not no one's avatar, let me check the firing stuff. All of this should be fine, but it's not. Doesn't seem to be actually launching anything. Fire. Let's get rid of that. Oh, we can't get rid of the tuple. We have to get rid of the objects inside the tuple. Yeah, so if you create an object on the server, it will automatically be created on the client as well. So we should see the objects show up where we created them on the server. Okay, so they do show up. I don't know why I couldn't see them earlier. Maybe I was just bad. Oh, I know why this is. This has nothing to do with the game at all. It's actually my my gamepad is kind of broken. So this bumper button is really bad. Yeah, let's add them. Let's add those to right trigger, I think. What's it called? Button. What? Right bumper. Thumb. So it's trigger, yes. I think we should be able to bind like a state to a trigger here. So map gamepad button what? Oh, okay, it needs to be mapped using that. So it's R trigger. So it's fire weapon, input source gamepad R trigger, and the context is that. And hopefully that should work. Yeah, so now when we hold down the trigger we can leave these projectiles around. Okay. So that's fine. And if we look at them, they look just like we expected. Might be a bit large, but it doesn't matter. Again, it's just testing stuff. I'm kind of tempted to actually just port this conversion code over from C++ to Zig so that we can actually get this get the orientation correct. But we'll see. Might do that offline because it's not terribly interesting content. Yeah, I'll do that now, and then we'll get back when I have the orientation sorted out. All right, we're back. So I have now ported this rotation matrix and local access conversion function in the quaternion, which allows us to construct the orientation properly in the projectile class, and it is working properly. However, there's a slight snag currently, which we ran into earlier already with when we did the aiming code calculation. So just quickly, this is how it looks now. So if we aim in that direction and fire, the projectile is correctly created in that with that rotation. So we can just do this, and we can see that it does indeed work correctly. So the problem is that when we do this, we fire the projectile and we get the aim direction out of the aim direction component. This is on the server, and as we actually ran into earlier when we did the aim direction math, we were running this only on the client local avatar. I commented out that if now like this, so now we run it on the server. We still only do the debug drawing. We do only on the client local avatar, like we want to, but we do calculate the aim direction, and this is of course the one that's used for the launching of the projectiles. Now the problem is that this matrix that we need to calculate that is actually only sent to us on the client. However, in the current version of the game, the camera doesn't move, the camera doesn't rotate. It does move, but it doesn't rotate. And for the direction, we only need the rotation of the camera. So I actually just went ahead and just hacked it right here. So hack to make the server side camera rotation match the current fixed camera rotation. camera matrix like this, and it does work. There's no problem with that as long as we don't rotate the camera currently. If we do that, then it's gonna get desynced. So we'll want to actually send the camera rotation somehow to the server, or alternatively we want to calculate this aim direction completely on the client and then send that to the server. Maybe that would be the simpler version to do, but we don't do that yet. I'm not gonna get bogged down by that because today we're looking at the weapons. And so now that we have the direction is essentially the local z-axis, the forward axis for the projectile. So that's why we use that as the local z. Local y is essentially up, and the projectile is not supposed to like be tilted upwards or downwards, just straight forward. So that's just unit y, and when we have those two, we get the local x by using a cross product of those two. And now I can then construct the orientation from those local axes. So that's the name as we discussed in the previous video. If you give it an empty name, it will just construct a unique name for the object. Projectile type, the start position, and the orientation. And so that's what we now have. The projectiles aren't that interesting yet because they don't move anywhere. So I think that's probably the next thing we'll do is we'll make them move, and then they should probably have some kind of maximum lifetime. So let's add a little bit of logic to that linear projectile component. So let's see if we can actually we move the object by using the transform API. There's a set position at least, so that looks good. Let's try to use that, and we can probably get rid of that. Let's add instead like a speed. What should we call it? Movement. Projectile speed. And this is in meters per second, so I don't know. Do it like 2 or something like that. And then we can change it later. And basically, in tick, we should update the position. Simple as that. So let's get var current pos equals self.context.transform.getPosition. And we can get rid of both of those because we're going to need both of them. And the current position is now then updated. So current position equals current position add, and we want to add essentially. Actually, we need to figure out the forward position of this guy, which we can most easily do if we get the orientation, which is a quaternion, and then we turn that into a matrix, which again I don't have, but I think that's supposed to be pretty easy to do. Let's see, from where is the code? orientation and position. Yeah, this doesn't look all that difficult, so let's actually just add this. Actually, we do have it. Yeah. Okay, so no worries. Yeah, I've actually added it previously. So so we need to get essentially the, where are we? We're here. I'm gonna actually just feed it the position, even if we're not really gonna use it. So it would be world matrix is what we will call this guy. Matrix for 3, and it is matrix for 3 from orientation, position, current orientation, get orientation, and we just feed these guys into this one, and we'll get a nice matrix to use. And the matrix will have forward direction. World matrix. So it's like it's that, guys. 3 1 3 2 and 3 3. Yeah, these don't need to be variable actually. I'll make everything constant. That's kind of how I like it. So forward direction is, it's a vec3, and then in it all matrix dot 3 1. That's actually that. 3 2 and 3 3. So that's just the middle row of the. No, that's actually the last row of the rotation, and that will give us the forward direction. Yeah. Okay, and yep. Now that we have that, we can just add it here. So we will actually. We can't add to current post because it's a constant. We'll want to do like an offset vector equals forward direction and we call it multifloat. I think we did. I think we added earlier. Where is it? Multiply float is what we call it. There we go. Up. Multiply float. And we'll multiply it first by the speed. And then we'll multiply it once more by the tick delta time. So that if we change the tick delta time of the game, the projectiles will still move at the same speed. Okay. And now we'll get like we get a new or updated position, which is current position, and we add the offset vector to that. And then finally we'll update the transform set position like so. Okay. Now for these, for these linear projectiles, we actually only need to do this thing once to get the forward direction, and then we can store that because it's not going to change, so we don't need to like convert between all of those. Do the quaternion to matrix stuff more than once. So let's just store here for forward direction vec3, and I'll just call that 0 for now, and we can do it in on parent created, for example. So something like this. That should be fine. Yeah, and we'll need to use self.forward direction, and we need to do the same thing here. Right. Well, that doesn't matter. The current position, we don't use it for anything. We can just put 0 there. It's only the rotation part of the matrix that matters in this case. Okay. So, would this work? Yes, it does work. They move really, really slowly though, so let's immediately up the speed. And let's make it, I don't know, 10 or something. And that should make it more interesting. That's of course something that would need to be tweaked, probably quite a lot. Like now you could already start to shoot these guys. Screw you, go away, go away. Yeah, you can almost, run as fast as those things. Now we can already start doing the classical twin stick shootery thing where you're moving backwards and firing at things coming at you. But yeah, this is already looking like something. I mean, the movement looks a little nasty though, because we're not actually moving them on the client. We're only moving them on the server currently. Which means that the movement that we see is just, it's coming in at every network update, and in between the client doesn't try to move them at all. So we'll probably want to have the client moving them as well to do the sort of in between frames. But yeah, it is starting to look like an actual twin stick shooter now. So that's fun. Okay. I think actually I'll want to up the speed a little more. Let me make like 13 or something like that, and then I think where's there? I think I want to do I want to have the player movement speed a bit faster as well. Character movement component. This is the one that we're going to want to actually rewrite this in Zig pretty soon, so that we have everything in Zig. But for the time being, let's just up it there in the C++ code a little bit. Yeah, this feels better. Now you can actually outrun those guys because you're moving slightly faster than they are, which is kind of what I wanted. I think maybe the firing speed should be a bit higher still, but that's easily tweaked. And let's get the warning out of there, or the output. For time between projectiles, just a little bit faster. Yeah, so here we could actually, with this we could actually already fend off like a pretty large amount of these guys. We can't really tweak this now that we have all of them like in a clump like this, just following us. It will be more interesting when we have actually like people coming at us from all directions, and we need to like quickly be able to turn and fire in the other direction, stuff like that. Yeah. Yep, I think this works quite nicely as a first version. So the next thing, which I'll probably actually leave for the next video, is the actual collision detection for these objects, and also we'll want to have like a maximum lifetime for them, because currently we just spawn more and more all the time. These guys never actually die. So if you like look around now, we just have like the whole world is full of these guys, and they just move in all directions. Hey, you can see the uninterpolated movement quite well. They don't move smoothly yet. So we'll want to add like a, well, actually we might not need to do that, because they will collide with the walls of the level anyway, and that's when they're gonna get destroyed, if not before that. But anyway, I think I'll leave this video here and do a little bit of research on how to actually do the basic collision detection for next time, and then we'll continue with that. And once we have that, we'll have our first actual simple twin stick shooter gameplay working for us. Okay, cool. Thank you, and see you next time. Bye.